Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar, An Introduction to Advanced On-Site Wastewater Treatment Systems. My name is Zoe Eisel from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. GoToWebinar has recently gone through an update, and you can now add live captions, raise your hand, or react using emojis. After the webinar, you will receive a follow-up email that includes a link to the recording and any other information you may need. You can also download the slides from today's webinar in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent within 30 days of the webinar date via email. If you have any questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application? Falling short on project funding? Not sure where to start? EFCN is here to help. Use the link in the chat to submit a request and receive tailored support based on your project's needs. And on that note, we can get started. I would like to introduce our presenter for today, Mark C. Noga, President of Night Treatment Systems and on-site wastewater professional with nearly 50 years of experience. Welcome, Mark, and I will go ahead and hand it over to you.
Thank you, Zoe. I welcome everybody. And let me get my PowerPoint going. And there we go. As Zoe said, I'm president of Night Treatment Systems in Oswego, New York, and been asked to come and do an encore presentation that I did this fall for a smaller group in the Skinny Atlas Lake watershed. During my presentation, any proprietary technologies, the use of my trade names as part of this presentation really shouldn't be construed as an endorsement. Use of material is purely for the educational purposes and to make people aware of its existence, the methodology behind it, and the availability in order to achieve effective on-site wastewater treatment. So we're going to do a quick review. Like to make sure that everybody's working off the same basis of knowledge when we get into the more technical aspects. And nearly every wastewater treatment technology out there primarily depends on natural biological processes to transform the wastewater into an acceptable quality for return to the receiving environment. And what it's really about is the organic food chain, the carbon cycle. Through the process of photosynthesis, we have plants that take the energy of the sun and combine it with carbon dioxide, water, some nutrients and other trace minerals. And what the product of this is an organic compound and oxygen, or the air we breathe. Then we have a group of consumers, everything from the insects through the lower life forms to the more complicated, that use these organic compounds as a food source. They get their energy from them, but they can't completely degrade that compound. So there's a byproduct called organic waste. And during this digestion process of the organics, cellular energy is attained, carbon dioxide is given off. And this can actually be done with or without the presence of oxygen. Finally, we get down to what's truly the true decomposers, or to complete the cycle, and that's aerobic bacteria. They're the only true decomposers that are out there, which take and expend the leftover energy. They take and release, combine it with oxygen, release the water and the carbon dioxide from which they came, and the nutrients. So it's a full circle event. When we look and we talk about wastewater treatment, there are three primary stages. Primary treatment is the removal of suspended matter and settleable materials and solids. In an on-site system, this is done at your septic tank. Then we get into the secondary, or the second step of the process, secondary treatment, where we rely on this biological workforce to take and break down the organics to relatively small and harmless compounds, and effluent by scientific measurement, typically no more than 30 milligrams per liter BOD or suspended solids. Then we get into the third step of tertiary treatment. And this is after all the biological processes have been completed, because it involves a removal of nutrients, nitrogen and phosphorus. I know you'll hear about some technologies out there that are talking about removing nitrate or phosphorus, but really, if they get ahead of the process and don't break down the organic constituents, you can run into problems. Organics are measured in a term called BOD, 5, the biological oxygen demand over a 5-day period. And a general rule of thumb in wastewater treatment is for every 100 parts of BOD organics you have, generally you need 5 of nitrogen and 1 of phosphorus to help the workforce. And we're going to talk about that a little more. Elements of wastewater treatment, the fundamental principles behind wastewater treatment are universal. They're the same for whether you're looking at a large-scale community treatment works or one of the small individual on-lot systems. What we have is we have a workload, okay? We've got organic constituents in the waste stream, and they vary widely across our society, whether we're dealing with a single-family individual home or maybe a commercial establishment that generate the higher strength wastes, such as a restaurant or a food facility. So knowing what the workload is really going to dictate what type of system is really needed to accomplish the task of complete wastewater treatment. So knowing that workload is very important. Then we got the workspace. Where are we going to try to complete this wastewater treatment? And your wastewater treatment system is much like a recycling factory. Certain things need to be disassembled or broken down and sorted out into elemental components for return to the environment. And workspace can highly vary where this biology happens. We'll talk a little bit about that. Then we've got the work environment. And much like you, myself, and the other people on this presentation, we all have optimal working conditions. Well, in the biological world of wastewater treatment, such things as the pH of the wastewater, the wastewater chemistry, the constituents that come down a waste stream. If you think of it, at least in my short lifetime here, I watched the waste stream evolve significantly. When used to start out that if you didn't eat it or essentially drink it, you flushed it down the toilet and that was it, and it was taken care of. Now we've got all sorts of cleaners, additives, chemicals, everything from disinfectants and body washes to non-biodegradable ingredients, and all have an impact on how the process works. We want to look at, such physical aspects as in the work environment as temperature. The biology is very temperature sensitive. Refrigeration, think of refrigeration. Cool temperatures slow down the process of decay. And that's what we're talking about here when we're talking about wastewater treatment. We want to erode or decay the constituents. And much like us, temperature has a big bearing on what we're capable of doing. Nutrients. Here again, I talked about 100 parts of BOD, certain parts of nitrogen and phosphorus, but there are also other elemental needs of nutrients in this thing. Just like us, where we need vitamins and minerals, the biology needs it also. Then we got the workforce, the multitudes of bacteria that are available out in the world, and science is still discovering more. And where the work is taking place is going to direct what kind of workforce we have. And not all the workforces and environments are the most optimal to break down certain elemental components, but we highly rely on this workforce. So when we talk about these things, we talk about the environment. In a conventional septic system, soil must provide the right conditions, both vertical and horizontal separation to aerobic conditions for the biological workforce to convert the waste into harmless byproducts. That's why in a traditional system, shallow trenches are best, long, narrow, shallow trenches. We don't want to have saturated conditions. We want to apply the wastewater and then give them a chance to do their thing and promote gas exchange. When you look at the soil profile or the soil interface, soil is made up of a very diverse, various size particles and types and shapes. And it's the spaces between these soil particles that are the conduits for fluid movement and gas exchange. When we get into some sediments, silt and clay, they're more uniform in particle size. They have just as much pore space available volume-wise, but they're a lot smaller. If we subject our soil-based systems to conditions such where you have ineffective septic or settling, septic tanks, particulate matter are always leaving the tank, even with today's effluent filters. Over time, what will happen is it'll cause a condition where we get a failure. Improper site conditions, soil conditions, or design considerations often lead to premature failure. I don't know how many of you out there are familiar with EPA's 2002 update of their on-site wastewater treatment manual. It's available online through the EPA, but if you go and look, there's a great chapter or section in there about wastewater application to various soils and what you might be able to expect for treatment. When we have a failing septic system, we are certainly providing contamination to ground and surface waters. And a septic system need not fail or need not come to the surface to be in failure of providing adequate treatment. Look at some of our coastal zones where nitrate loading is very, very important. Dealing in some very porous soils and coarse sands, we're getting nitrification of the ammonia in the wastewater, but we don't have a chance to denitrify it, and it'll cause coastal issues. Surface breakouts in freshwater zones. It's the phosphorus normally can get bound up by iron particulate in the soil, but when it comes to the surface and is captured by stormwater runoff or overflows, you're going to have eutrophication of the lakes. So there's understanding forms of on-site treatment technologies, to identify acceptable options, is very, very important, whether you're in a freshwater or coastal zone. And there's a wide variety of techniques out there. And, if you think of them like automobiles, okay, automobiles are universal in name, but each one has maybe a different property or a different attribute that'll do a job. Do you use a passenger car to a job that you need a dump truck? So we're going to talk about these a little bit. The advanced on-site treatment system, there's really nothing magical or mystical about them. They've been around for an awful long time. And most of the innovative technologies out there simply provide a more friendly workspace and environment that efficient biological treatment can occur. Time is also important. Just like we need some time to eat a meal in a comfortable manner, the biology needs to be able to have enough time to break down the wastes. And wastes can come in very simple forms, such as sugars, more complex forms, such as fats, oils, and greases. So here again, many of these technologies out there are looking at providing and managing the operational environment for the biological workforce. In a large-scale municipal treatment works, you've got people that monitor this every day and make the adjustments. There are some systems out there now for on-site systems that are making that remotely possible, so you don't have to have a human being physically present every day. And the fact of the matter is that distributed wastewater treatment on site is quickly picking up pace in our world. We can no longer afford to sewer the world. It's been a realization for many years. So some type of management is very, very important. And here again, managing, the environment and the water chemistry and work conditions can get quite complex. There are a few technologies out there that are actually, instead of relying on the random and inadvertent selection of the biological workforce, science and biology has evolved to the point today that there are some technology suppliers out there that are actually putting a select group of microorganisms, introducing them and turning vessels into nurseries where these more aggressive forms of organic consumers can accomplish things in a lot better than what would naturally populate a liquid environment. Give you an example. Back in my day, the Exxon Valdez ran aground up in Alaska and released a phenomenal amount of crude oil. More recent is the Gulf oil spill with the platform that gave up and gave up millions and millions of barrels of crude oil. There were actually physical locations out there where the crude oil couldn't be cleaned up, and science had allowed a group of microorganisms, or was discovered a group of microorganisms that readily digested crude oil in place could be used. That same type of science is being used today in on-site wastewater treatment. And more recently, with our interest in nutrient reduction, there are some processes that have been developed where it's absorption or bonding to various types of medias, like a magnet would pick up steel. These compounds would absorb phosphorus. But here again, it's very important that phosphorus needs to be available, or at least a portion of it, until the end of the biological processes happen. There's a technology showcase, and this is actually all not that new. This is what I originally did this presentation on. It's a City of Syracuse Skinny Atlas Lake demonstration project. It was part of the National Decentralized Water Sources Capacity Development Project. And back in 2002, a grant was provided to the City of Syracuse to put on this technology showcase. Funding was provided by US EPA. There was a project coordinator and manager, and what it involved was the City of Syracuse Skinny Atlas Lake, primary drinking water source for the city. It enlisted the aid and the guidance of the various agencies in the watershed, Syracuse Department of Water, New York State Department of Health, Department of Environmental Conservation, the 3 county health departments, and then the New York State Onsite Wastewater Treatment Training Network. Back then, Skaneateles Lake watershed had been managed since the late 1800s. They're very adept on what they had in their watershed. The inventory at that particular time was almost 2,000 conventional systems, 340 dry wells, holding tanks, composts and stuff and such. They put together a technical committee from the people that had joined the stakeholder group, and they went into design considerations, treatment cost, operation and maintenance, and system dispersal. The primary focus of this technology demonstration was to eliminate seepage pits and dry wells that were within 100 feet of Skaneateles Lake. As I said, Skaneateles Lake water, actually it's one of the largest unfiltered drinking water supplies in the United States. They don't put it through any kind of filtration system right now. They simply chlorinate it and put it into their reservoirs. Now, when you look at traditional conventional treatment, the soil types and the topography of Skaneateles Lake really aren't conducive to doing traditional in the soil-based treatment. So they looked at technology, and this was a technology demonstration project. Okay, they're looking for technologies that would deal with steep slopes and shallow depth of bedrock. Very little or no separation to surface waters, multitude of summer residences and such, built right on the shore of the lake. Extremely small lots because waterfront property are very high in value. And then here again, steep slopes, very, very concentrated watershed. If I remember correctly, I think it's like about 93 square miles is all that watershed, very steep slopes, runoffs occur very quickly. In preparing for this presentation, I thought, well, geez, let me do an AI search because it's becoming a big thing. Let's see what it comes up when I pose the question, what's innovative in on-site technologies? Talk a little bit about them. Aerobic treatment units, simply, it's just like your large-scale treatment plant, fixed film and suspended growth, force air into wastewater, and allowing biology to happen to help break things down. Recirculating sand filters, they've been around for a long time. Aerobic units have been around for a long time. Constructed wetlands, depending on what part of the country you are, they may be a solution. They certainly wouldn't be up here in the northern part where we are, or I am right now. Advanced treatment medias and filters, it's all about fixed film, and we'll see a little bit about that. Nutrient removal systems, I spoke about that a little bit. Then you get into some distribution techniques of the soil, low pressure distribution, using different things versus rock trench, microbial biological process enhancements, advanced biological treatment. I talked a little bit about that, where it's made its way out of the petroleum industry and renovation to contaminated soils. Disinfection technologies, you know, the most popular that we were really familiar with is chlorination, but chlorine residuals are carcinogens and can cause a problem. So now we're looking at ultraviolet light is out there and ozone for high disinfection. And then, you know, some innovative toilets, composting, incinerettes, you know, for those who are able to take care of them. So when the Skaneateles demonstration project came to be here in the early 2000s, what they were going to exhibit, gravelless types of technologies. That's where instead of a rock pipe trench system, medias were introduced underground, you know, via pipes and such, synthetic materials to grow the biology on instead of the surface of the soil particles. You had aerobic treatment units, talk a little bit about them some more. You got your different media filters, sand, textile, foam, and peat, microbial generators, nutrient reduction, and composting. So this was what was put on at the demonstration project. And they set some preliminary requirements when you're looking at these innovative products. It should be pre-engineered, small footprint, needs a proven history of performance, disperse clean water, and we'll talk a little bit about clean. It should be clean in color and eliminate clogging of the dispersal system. And what they did is they turned to and we're looking for NSF Standard 40 Class 1 systems. NSF Standard 40 Class 1 is a yardstick that manufacturers can come and put their product up against to take and be tested to treat an individual residential system's wastewater from a single family home. It's not a standard that you should use to govern multiple system cluster systems or high strength like restaurants and such. There are other ways and means of doing it. Standard 40 is an individual residential home system, and it's for a complete system too. What the technical committee was looking for is any supplier of these products to have written instructions on both their installation and their maintenance and their applications. What can they do and what can't they do? The project involved sampling and analysis by an independent third-party entity looking at biological organic content, total suspended solids, ammonia, nitrate, total alkaline nitrogen, phosphorus, pardon me, total coliform, fecal coliform, and turbidity. A number of project sites or homeowners were able to submit for grant money. If they met the criteria, 19 systems were put in. 18 of them were residential, and there was one commercial system or restaurant at the southern end of the lake called the Glen Haven. Aerobic treatment units were in place. These are two of the more popular here up in New York. I'm sure that you've seen them across the country. You know, you've got your fiberglass containers, concrete containers. We had many foam textile filters, Waterloo biofilter, prepackaged systems, Zabel aerosols at the time. What they do is they afford higher loading or organic loading and hydraulic loading rates. They have blowers involved. They were containerized. They can do a good job. Textile filters, open foam. What it does is it offers greater surface area, periodic dosing with control panels. Normal dosage, you know, when you're looking at soil characteristics, you know, if you can introduce a gallon per day per square foot to the soil under decent conditions, you can give phenomenal loading rates to these textile filter type systems. Peat systems, peat moss, because of its open cell structure, very tough to degrade. A number of these were looked at and put into the system, a couple of them, PureFlow, EcoPure, trenches, very important. Nutrient reduction, here again, I spoke earlier that, you know, nutrients, nitrogen severely impact water quality, can affect public health. You know, drinking water supplies out on Long Island, for example, they've contaminated lower aquifers with nitrates. There's a big push in that area and other areas of the country, Florida being another. You know, not only nitrates there, but, you know, the phosphorus also. Traditional on-site systems are extremely limited in their ability to remove the nutrients. Nitrogen reduction is actually fairly easy compared to phosphorus. It's a biological process. What happens is you've got organics coming in. You need to break them down totally. And when you have low BOD and lots of available free oxygen, another bacterial workforce comes in and takes and accomplishes nitrification. There's also another process called ammonox, which is a direct path for nitrogen to be removed from the system. Recirculation is the best way to accomplish it when you've got a good, robust treatment works that breaks the organics down, takes and produce secondary effluent, can be recirculated to the head of the treatment works, but you need to have a carbon source for this biology in an anoxic zone, meaning not totally anaerobic or without oxygen, but very low oxygen concentrations. The way it's being accomplished today now with sand filters, media filters, ATUs is recirculating it back to the head of the treatment works, the septic tank or the trash tank, doing it on a managed basis. Very, very successful. Recirculating sand and media filters can be configured to promote that denitrification. Phosphorus right now, very end stages, ionic bonding, two media. Some medias are susceptible to clogging. I'll leave this to you. 20 years ago, I was involved and we patented an effluent filter that used various medias to take and capture the phosphorus. And looking at previous work in that, what was happening is if you tried to do it prior to the biological stage, biological films would develop on the media and use it and create it as a magnet, attracted to, it's like putting an insulation on the magnet. It got to the point it couldn't take anymore. So here again, for those of you who are looking at nutrient reduction, make sure that you get a very, very high quality effluent if you are going to, use one of these ionic bonding type materials. The key to the success of any of these advanced treatment technologies is the greater the post-installation attention that it receives, the better it's going to perform. Under NSF Standard 40, they require that aerobic units are minimum serviced at least twice a year, 6-month intervals to make sure that they're operating properly. There's many localities out there that will not allow the use of an advanced or an innovative system without some type of service agreement and management entity in place. The more complex the system that's out there, the higher degree of maintenance. There are systems out there now that are using membrane filtration, like the principles of reverse osmosis to remove the pollutants and the organics, and even right down to the minerals out of the waste stream. And you got to pay attention to this because they do have a waste product themselves. The washings from the screen need to be addressed somewhere. So you're preventing them from going one way, but you got to take care of them another. So, just be aware of that. Membrane filtration in small on-site systems, can be quite complex. Mound systems, pump stations, service entities really need to be on top of their game. It's just like automobiles now. There are a wide variety of products out there. Many of the replacement components are proprietary to the provider. So you want to make sure that you get competent, qualified entities taking care of these things if you're going to use them. So that's my spiel about advanced on-site systems. Open up the questions. Zoe will take your questions and provide them.
All right, I want to encourage folks to put questions into the questions tab on GoToWebinar so I can share them with Mark. We'll give people a couple seconds to do that. All right, our first question is, how much do maintenance service contracts cost?
The cost of a contract is dependent on the type of technology that you're servicing. I can tell you that Night Treatment Systems services several hundred systems here in New York. And depending on the size of the system, they can go from a few $100s to commercial systems that can be a couple $1,000s a year.
Thank you. Our next question is, what is the most common mode of failure you've encountered for these type of systems?
For the advanced systems, lack of maintenance will cause them to fail. In a traditional or conventional system, lack of maintenance, people not maintaining their septic tanks as they should. Some are into thinking flushable additives are the answer in lieu of pumping. And there's a wealth of information out there that hasn't shown any true benefit to using flushable additives. They can actually, some of them out there, cause premature failures.
All right, our next question is, are there innovations that can be added to typical leach line systems in areas with increasingly high water tables?
There were some products out there. One brand name was called a no mound, where they actually domed the leach field and used a compressor to force compressed air and to artificially lower the water table. But there's technologies out there. You can't make water go where it won't naturally go, and you need to maintain aerobic conditions. There are techniques out there to lower water tables through using curtain drains and a pump system. It's another method of doing it, but it's tough. Mound systems, you can import soil and raise the treatment bed up above the saturated soils. That's another method.
Thank you. Another question is, do these systems usually require electric? And if so, how much electric?
The mechanical systems that are used, mechanical aeration, do consume electric. There are products out there that aeration using small lineal air pumps that draw about as much power as a light bulb. And there are others that are use massive horsepower blowers. There are some passive systems out there that rely on ventilation of the dispersal system under the soil or in the ground to help pull oxygen through the soil. To do that, in fact, I actually rehabilitated a sand filter a couple of decades ago through the underdrain system by extending up the underdrain ventilation stacks and putting one of those little whirly ventilation gigs on there that help spin it to pull it out. So there are some means to avoid power. A lot of it's going to depend on the workload you need to handle. May be suitable for a small single family home, but you get into large families or even home hobbies, baking, hairdressing and stuff, you can cause some problems with those systems.
Thank you. We have someone requesting that you discuss the cost of the system types.
Oh, the systems can vary. Typically what you do is you look at what your own traditional system would be in your general area and figure that you're going to at least double the cost for an innovative or advanced treatment. I've seen systems in some area of the countries go $30,000, $40,000, $50,000 depending on the locality that you're in. There are some systems, if you've got the right soils, that are only a few $1,000s. When you want to live on a water body such as Skinny Atlas Lake, where homes sell for the millions of dollars, putting in an advanced treatment system for $20,000 probably isn't the same amount of money that you spent on the granite countertops that went in the homes. People spend a tremendous amount of money on what you can see around these types of properties, but when it comes to wastewater treatment, they just really don't want to spend the money. So it varies here again. And what's also going to impact is local regulatory requirements. And here again, you know, the density of population and what's required.
Thank you. Is there a way to assess contamination of groundwater near an on-site system?
Yes, you can put in monitoring wells, and it's done at many of these technology demonstration sites. Put in it's a device that actually collects the groundwater. It's withdrawn and sent to the laboratory. Actually, it's done quite a bit around landfills right now. So same thing with wastewater systems. Read an interesting article a while ago on a lake association that what they would do is in cooler weather times, like the spring, if they're looking for contamination, they'd fly around and use infrared to see where the heated streams plumes were coming from the residents around the lake. Generally, caffeine does not naturally occur in the environment. And I've read another interesting article where the water samples are looking at caffeine and actually some other substances found in pharmaceuticals to see whether, you know, on-site systems are polluting that body of water.
Thank you. Do ATUs require sludge removal?
Yes, periodically, sludge does need to be removed. Some of the units out there have what they call a trash component or compartment, a multi-compartment tank. And your service company actually should monitor and record this. And for example, what we do is we give homeowners a 6-month early notification that the aerobic unit should be pumped out, and coordinate that pump out with the next service, be it spring or fall. And the reason being the sludge removal is the bacteria that naturally would populate the aerobic unit are not good at breaking down the cellulose that makes primarily up the sludge and the non-biodegradables. They just don't naturally populate that. They're good, you know, BOD or organic content actually comes into 2 states, a soluble and an insoluble form. And so what do I mean by that? Well, think of coffee or tea. Okay. You brew a pot of coffee or make a cup of tea. The color and the flavor in the liquid itself is a soluble component of the organics. The insoluble are the coffee grounds or the tea leaves. You know, your solids are they're one of the most complex carbohydrates that Mother Nature produces is the cellulose.
Thank you. Will advanced treatment systems allow an on-site system to be used over karst geology to lower the required vertical separation?
Here again, it depends on whether, you know, the fact of the matter remains that science exists to treat wastewater under any given condition. As long as you've got enough money and you've got the ability to put it in, you know, you look at the space station and they recycle their water up there through membrane filtration, but they do bring back, you know, the residuals to be disposed of. They don't keep bringing fresh water up there and then releasing it to space. So the technology exists. The question is, can you afford it? And will the people that, you know, control the rules of the game, if you will allow it?
Got it. Thank you. Should the leach field lines from a septic system be flushed periodically?
Well, here again, you know, if you've got a problem, a lot of solids building up in them, you know, flushing the lines, it'll tell you the condition of the soil or what's going on. But mind you, if you got to flush the lines, there's your typical leach field pipe, 4-inch diameter. It's got 1/2-inch openings or maybe a little less at 5 and 7 o'clock. If you've got solids laying in those lines and then escaping the holes and going out into your gravel, chances are you've already got a problem. Yeah, you could short-term go and jet the lines and suck the solids out, but that's really not, it's only a temporary solution to the issue that's going on.
All right. Are most septic maintenance servicers familiar with innovative and advanced systems, or do you need to find a special servicer?
It depends on what's used in the area. There are some providers that go and go to trade shows and continuing education to learn about what's coming up and on. There are manufacturers that provide training to people that are handling or selling their products to make sure that they're up to speed with what needs to be done. But there are many out there that are, undereducated and, will not do the right thing and say, no, I can't handle that. You got to go to Charlie Brown, who's a dealer for this particular type of treatment technology.
Could you discuss the current consensus about the benefits of additives and other enhancements to improve system performance?
Well, here again, it depends on what you're adding and such. I can tell you that, academia, the EPA has released technical papers on it. What'll happen is here again, many of these flushable additives defeat the primary purpose of a septic tank by adding either chemicals or enzymes to a device that is supposed to separate separable materials. In a septic tank, you've got your floaters, typically your greases, fats, oils, soaps, and then you've got your sinkers. And liquid is drawn from the center of the tank because it stratifies and it goes. Some of these additives will actually take an additive or an enzyme. There's nothing more than a tool that is created to take a complex compound and reduce it down into two more simpler substances. So you've got additives for grease, for example. What it'll do is it'll take that and defeat that scum layer and turn it into a more soluble state and send it down line so that there's more work for the workforce to do out in the leach field. There are other things that just take those solid contents and mobilize them and cause them to to leave the septic tank. And once you take that workload, just like any of us, the less work you place on us on a given task, the better we are at the task. When you overload us, you're going to have problems. And here again, if anybody would like any information, my next slide is going to have my email address on there. I've got supporting information. I'm kind of like a pack rat or a nerd when it comes to technical things. Anything that I come across is in a technical nature, studies or that, I save those files and I'm happy to share them with anybody who requests them via email.
Thank you. Our next question is, how do you develop an efficient pumping system across high-grade drops? Is it better to have multiple pumps, high pressure / leak resistant piping, even when considering maintenance?
What type of, I'm not as familiar with working on mountainsides as I am working in the Finger Lakes. High degree of solids removal in deep well pumps will pump effluent up. Modified drinking water pumps will do a great job. The key is you want to make sure that nothing gets to the pump like the can get out of the tank. Use of effluent filters. You really want to screen it to get it up the slope. Grinders, grinders are used. They've been used in municipal sewage treatment and stuff, but there's a real battle going on with the flushable wipes and the Depends and the disposable diapers. Municipalities hate the flushable wipes, as do normal septic system pumpers, because they don't break down like toilet paper, and they can cause some real issues with these pump systems. You could do things in stages too, I guess. A lot of it depends on how far you got to get away and what you got to, the depth of area, the force main, size of pipe have a lot to do with it. So these are mainly engineered systems. You need to get a good engineer who's competent in the field, to come up with, what you need to solve a particular situation.
Thank you. You might have touched on this a bit, but our next question is, how much space does a membrane system take up for a residential home?
Membrane filtration, well, you're going to have a septic tank, and then it's a box, and it depends on the volume of water, and then you've got a place to have to dispose of the water from the membrane. They're used New York City watershed, in the Catskill watershed region. I know they were upgrading all their municipal plants to include membrane filtration, but I don't know of very many people that are trying it firsthand to give you a really qualified answer on that. I can tell you on a drinking water supply, the most efficient RO system out there, for every gallon of water that it yields, there's two gallons of water wasted due to the scrubbing of the membranes. I know that when we, as a company, went out to the Eastern Caribbean to install systems, out there they don't have any naturally occurring fresh water. Fresh water is manufactured typically by the power company through either reverse osmosis or distillation in the very early days. And we were concerned about the lack of trace minerals and such, and being able to, keep our biological workforce in the place that it needed to be. I wish I could help you more than that. I'm not a big fan of membrane filtration. They require a lot of power and a lot of attention, and there's quite a upfront cost. There's other ways it would be more beneficial in addressing things.
All right, thank you. Our next question is, do some advanced treatment systems have sensors sending data to a display at the household or business to give a sense of required maintenance?
Yes, there are more and more firms coming up. We pump stations, we do pump stations for apartments and such like that, where we have data collection in the pump control panel. There are companies out there that provide remote monitoring of systems. Typically it's flow, liquid level, and maybe solids accumulation. As far as treatment efficiency goes, you can do residual oxygen readings on the effluent stream, that type of sensing. But as far as overall biological performance and BOD reduction, I don't know if there's anything out there. I haven't seen anything that would tell you that, yeah, I'm meeting my secondary wastewater standards. That typically requires a physical sample to go to an accredited laboratory.
Thank you. Our next question is, how often do the peat material, foam, etc. have to be replaced?
That's a good question. I know Dr. Joan Brooks, or I knew her back when she was doing trenches with peat on her own residence and stuff. And the peat systems that we've taken care of, typically it's gone about 10 years or so. And some replacement peat was necessary to go into the system. It's going to, vary depending on the wastewater strength coming in and and other constituents. But there are systems out there that I know of that are 15, 20 years old with a peat. Type of peat, I know that Dr. Brooks, when I was conversing with her, the key to peat, the successful key to peat is the density of the peat and the type of peat. And I think you can probably look up her research. She used to work she did some work for National Precast Concrete Association and septic tank efficiency. She's worked for all the major peat suppliers out there back in the day. You may still be able to find some of her research online.
Thank you. Our next question is, how is phosphorus important to biological treatment?
Well, here again, just like we require certain vitamins and minerals or nutrients in our diet to live, thrive, and carry on, the biology, the microbes are the same way. They need a certain amount of phosphorus in their bodies. In intake, they replenish it periodically, just like nitrogen and other magnesium, manganese. It's just the fundamentals of life. We've got certain things that we need. So here again, phosphorus, typically here again, 1 part of phosphorus for every 100 parts of organic. Typical effluent, you see, here again, depending, the world of wastewater has changed. Let me put it that way. Back when all our cleaning products were made of phosphates were a big thing, because phosphate grabs onto soil and takes the dirt away from our clothes. When phosphate was banned from cleaning products, other materials were substituted. There are some good technical briefs and papers out there on phosphorus needs and uptake. Drop me an email and I'll get them to you. So that you can learn more about it.
Thank you. And we'll try to squeeze one last question in, which is, have there been any follow-up on the long-term performance of the EPA demo projects installed, such as at Skaneateles Lake?
It actually, the project is now going into 20 years. There had been periodic tours going around, and all the systems that are in there right now are still in place and working fine. I was involved with a meeting with EPA here a handful of years ago, where they were talking about going back and revisiting a lot of these demonstration projects around the country and providing an update. And at the same meeting that I was invited to, they talked about updating. Why don't you put some appendixes in the 2002 EPA on-site design manual? It was, it was 20 some odd years since the 88 Red Book or whatever it was called back then. The 2002 manual updated. We've gone another 20 years. Let's anybody who's from the EPA and you're looking for something to do or talk to your boss, let's get some updates to some of these projects that were funded with EPA money a long time ago, and that would help answer this question too. I can only speak from what I know. It's in my backyard, and that's the Skaneateles Lake, and they're all doing wonderful.
Thank you, Mark, and thank you everyone for being so interactive during this Q&A session.
Yeah, if you're looking for my email address is Mark, M-A-R-K, at Knight. Knight begins with a K, K-N-I-G-H-T, followed by the word treatment, TREATMENT.com. Mark at nighttreatment.com, and it may take me a day or two to get back to you, but I do reply to all questions.
Huge thank you to Mark for sharing his expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar so you can let us know your thoughts on today's presentation, as this helps us plan future webinars on topics important to you. Thank you again, everyone, and we hope to see you at future EFCN events.